guys, welcome to my YouTube channel. And today I bring you another exciting video about generative AI. Gen AI is the hot and trending topic of today's industry. What is Gen AI and how we can use Gen AI to solve business complex problems? So basically generative AI is a technology through which we can create very efficient chatbots who can do conversation with us, who can solve, who can trigger inputs for us. They can interact with different chains. And here we go. So I'll be demonstrating a simple chatbot application which is made and developed by using Langflow. So as you see, this is the Langflow website. You can download the Langflow framework from here. The Langflow framework is very good. It's a low code platform which provides various components which you can use to create and design a workflow kind of thing, and using that workflow you can create a very good chatbot. The Langflow has full support for different large language models like ChatGPT and Vertex AI. Going through the website, it's very easy. You can create prompt variables, you can create chat input. It creates a kind of quite a good UI. I'll not say a very great UI, but it's a good UI for you to start with. You can call the REST API URL which is provided to integrate and create your own UI and trigger these workflows. So here we go. Let's deep dive in and see the chatbot which I have developed using Langflow. So hello guys. So now first thing, what we want to build our chatbot, we need to understand how LLM works. So these are large language models like ChatGPT and Vertex AI which are trained on a large, huge amount of tera or petabytes of data. They have trained on months, Wikipedia and whatnot. The data is humongous, which is not easy for an individual to train the model. It's cost a lot of money as well. So companies like OpenAI, Microsoft, Google are investing a lot of amount money and labor to bring large language models. So they are the LLM providers, and as an application developers, we are the consumers of these LLM providers. So the business model you can see is that there will be few companies which will be creating and investing in bringing a lot of new models. They will sell on a pay per use basis on the maybe the API calls or the tokens which you are using to call these APIs. They'll make money out of you creating the generative AI models. And as companies and the other enterprise or the individuals or the startups will use these LLM models to solve complex business problems for the end users, and whatever suits in their business context, and they'll be earning in their own domain. So let's get deep dive into how to create a chatbot. So first of all, we need to understand, like, when chatbot is trained on a this LLM, sorry, the LLMs are trained on a different sets of data. Your domain data is altogether different, and that data on which a LLM is trained on may become obsolete as well. But your domain data will keep on increasing. So, is there any way that you can pass this information or the heavy information or the domain related information or the documents and the knowledge, PDFs, whatever documentation you have on your conference pages or in your internal Jira's, and you install them on your own premise solutions? How can you can pass this information to a LLM? So yes, here comes the technology which is known as RAG, retrieval augmented generation. So that the way is that you can pass all this information and transform that information using vector embeddings. Each LLM provider provides the supports for embeddings like Vertex AI and OpenAI embeddings. We will see that how we are using these OpenAI embeddings. These embeddings will be passed and persisted in a vector store, and then LLM will query this database store to get the information or to retrieve this information and then create an enhanced response for the end user. So first of all, we need some kind of data. So let's log into the Indian website data.gov.in. So my favorite websites, here you can get a lot of data which is published by government sources, and this is, by the way, this is a real-time data. It is owned by Indian governments. You have to register on this website to get the data. So what I've done is that I have searched for Kisan Call Center and downloaded the scripts. So these are the scripts where a farmer calls on the Kisan Sevas Kendra, and the KCC agent provides the information regarding the farmer subsidy or the agriculture related questions to the end farmer. So I have taken 1 month of roughly of data of Delhi NCR region, and it's available in a JSON format to download. And if I see that I have kept it, this is my VSS notebook, and here I have kept this information. So if you see, this is a column based data, the CSV information, Delhi, East Delhi, sector, crops, query type, and what was the KCC answers. We'll be using this on, we'll be storing this information in a vector store for our large language model to use. Let's go ahead. And once again, so as I've told you that we will be using Langflow. You need to install Langflow on your machine, and once you install, you run the command langflow.run, and as soon as the Langflow component is run, like if you see here in my VSS, I have, let me launch my VSS tool. Okay, and then we will start the Langflow. So I'll show you once the Langflow is installed, how we can start. So here is my terminal, and I'm typing command Langflow run. As you see, the Langflow component will start running, and then we can access that particular endpoint to use the local framework on our machine, and then we can start designing the workflow. So see, the workflow is available. The Langflow framework has been initiated. The Langflow now low code platform is ready for us to use. So at this URL, so this is the URL, and if I log in and see, so I was connected, I got disconnected, so I'm connecting it again. Yes. So you see, this is the Langflow. So for this demo purpose, I've already created a chatbot, and I will be showcasing how the different components I have used for Langflow. So if you see, this is the entire workflow, a drag and drop software to create the chatbot. We will shortly, shortly demo the chatbot first, and then we can get started. So guys, first of all, I will be giving information about the RAG tool. So let's see how we can create. So first thing was that I showed you that the data, which was this, how we can store it in a vector store database. So I can, you see, this is the workflow which I have created. Here I have a file component, then I'm splitting the file in terms of chunks to save. And I have, for a vector store, I have is a ChromaDB component. And here I have used OpenAI as embeddings, which will be like a kind of format, you can say, which OpenAI will, which have OpenAI have provided to us, and these embeddings will transform this particular data which is available for as in this format in terms of embeddings, and we will be storing it in a vector store. So let's get started. So if I see, it's very easy, drag and drop. I'll just show. So let me start. So this is the first file component. Here I've taken this file component here. So in this file component, I can just mention where is my database or the JSON file for the information which I need to store. So once this file component is ready, I can just take this input and drag and drop, give it to my split context. So since I already have this component ready, for I'll remove the extra component. And now if you see the split context, so why I have used the split text component. So split text is that what I need to do is that I need to convert. So for the split text component, what we are doing is that, say, the file can be a huge file when we are trying to store in a Chrome vector store. So what a split text component will be doing is that we'll be storing this information in terms of chunks. So what this component does, takes the input of the file component and in chunks this information. So here is my ChromaDB component. Here I mentioned the collection name, which is like the vector store name where the information is getting stored. I provide the location as in my local where this file needs to be stored. The vector store is will be going to store the information at this location. We leave the search query for now as blank. The search query will be used by our LLM to query the data from the vector store. And here is the OpenAI embeddings, which I'll be using to convert this stored data into kind of some embeddings, which are specified by OpenAI and store in the Chroma store. So once all these components are ready, you can always search the components from here. So if I see ChromaDB, you see the vector stores. And just by the way, A lot many vector source support is being provided by Langflow, like Astra, Cassandra, Chroma, Couchbase, etc. So once this workflow is ready, just click on this button and the component will start getting building as you see here. So once the components are built, you will see a small tick mark as green, and that means you are ready to go. So in this workflow, what I have done is that I have stored the information the which will be used by LLM in terms in a vector store to create a correct contextual information as a response to the end user. So as you see, our workflow model to store the information in the vector store is ready. Now here comes another workflow, which is the actual workflow for the chatbot. So you see a lot of different components have been used, and I will be explaining each and every component. So let's start. So our first component is the chat input. So if you type here chat input, so you can just easily drag and drop. Okay, so as part of the workflow, since I do have the chatbot there, the system gives me error. But it's easy. You put the chatbot, after the chatbot component, your first thing is that whatever information a question is being put, we have to provide that information to the LLM. So the chat input is passed to the OpenAI model. From the OpenAI model, OpenAI, what as we talked about the RAG, right, retrieval augmentation generation, the OpenAI will query our vector store to see what kind of information is stored in the vector store in terms of search query. So the output of the OpenAI is provided as a search query. After the search query, once the OpenAI queries your vector store, it gets the information. And remember, we are using OpenAI embeddings in terms of compatibility, and OpenAI embeddings are being used as an embedding in the Chroma DB component. So one thing is like when you will be dragging the OpenAI component, you do need to provide the OpenAI key. So either you can create a global variable like this, or you can store the direct key here as an OpenAI key. What is the model of OpenAI which we are going to use is GPT-4o mini. So once our OpenAI configuration has been done, we take the output of the Chroma DB and pass it using a parser component. So this parser component takes us data, convert it into text input, and that text input is passed as a context in our prompt. So prompt is kind of prompt engineering for we will be I'll be having a separate session in which I will giving more details how to create an effective prompt for LLM models. So for now, you see that prompt, you can just assume this prompt is a component which provides kind of instructions to the LLM. On based on that, LLM generates the response for the end user. So output of the question output from the message, I'm also passing that question as to the prompt. Now if you look at the prompt which I have created, is just the context. This context is the vector store embedding and the text and the parser, the workflow for that entire output here, and I am generating I'll be requesting the LLM to through this prompt like answer the question based on the above mentioned context. So once that prompt is given, I pass that prompt again to the OpenAI, another OpenAI component. I've used the GPT-4o mini model. I'll keep the temperature as zero point 0.1. Temperature is nothing but kind of variable through which a randomness can be generated, like zero point 0.7. You get a different answer every time. So here I've just kept its temperature as zero point 0.1. And then final output of the LLM is given to a chatbot. Chat output. So if you see, the entire workflow model is very simple. And once your entire components are created, you just click on this build button. When you will build the component, a tick mark will be generated if no error is thrown. So once I've already built this component, let's go on the playground. Here you go. So I'll remove the default session and start asking the questions. Remember, my chatbot is based on Kisan Seva Kendra or Kisan Customer Care uh, data. So this data is very useful. And as we all know that India is an agriculture based country, right? We have a huge economy built all over around agriculture, and in government of India have Kisan call centers where a farmer can call and get the information regarding agriculture information, what kind of subsidies, what kind of policies, what kind of whether what kind of crops can grow, and all information regarding farming that can be received from the Kisan Seva Kendra. So let's see, does this chatbot understand that through the information which we have given in terms of that file and stored in the vector context? So let me ask chatbot, hey, what can you do for me? So chatbot is thinking. So give the LLM time to think, and then based on, because LLM will be querying your vector store to get this information as well, and then generating the response. Hello. So see, the chatbot have generated with a very, as I mentioned, it's based on the KCC data. I can assist you with a variety of agriculture and horticulture inquiries. So bingo, our chatbot is ready. So, based on just 30 minutes, we can create an efficient chatbot and, go live with it and help others. So for example, if government of India, have these chatbots all around different states of India, this can be very useful for farmers. They can just query instead of getting a call and get all the information. Indian government can save a lot of time and information, because similar questions will be asked by different farmers in that particular region, or based on that geolocation, a data can be created, that context can be passed to the LLM, and information specific to that particular region can be generated by the LLM. So, for example, I have used the Delhi information data. So, if I ask what is the subsidy, so let's see if this any information have regarding our government scheme or a plan, if the chatbot is able to understand that. If it not, and what kind of response the chatbot will generate. So yes, chatbot has some information regarding the government schemes which is provided in terms of subsidy. 100% subsidy on purchasing drones, tell like INR. So all this information is provided. Subsidy on the ShedNet house. This is a question which for sure I have seen the response in the Hindi. And one more thing, chatbot is these LLMs are very smart enough to understand language of the end user. For example, if I type in Hindi, which is the national language of India, and if a customer is talking in a different language, maybe German or Spanish, the the LLM will try to answer based on that. So let's say, hey भैया कैसे हो? So I'm just asking LLM, how are you? It's in Hindi. So let's see if the chatbot can understand and respond in the English model. So see, yes, the chatbot is responding in Hindi. Namaste भैया, मैं ठीक हूँ. So I hope you guys have liked this video. So in my GitHub repository, I will be providing a link where I have exported this chatbot JSON file. You can directly, import the JSON file by clicking this button. Okay, and the information where this JSON file will be saved, because all this information or this model, if I export is, if you see, I can export it. It will be exporting in terms of in a JSON file which you can import from here. And that's it. And if you have any question, you can ask me on my YouTube channel. Just share with this video with your friends who are interested in data science, and you are very much interested in using generative AI technologies. Keep commenting, keep sharing the video, and if any question, do reach out to me. Thank you. Thanks for watching this video.